Hi, today we discuss how to convert electrolytic cells into electrochemical cells or electrochemical cells into electrolytic cells. You know that electrochemical cells are the cells to convert chemical energy into electrical energy. In the same way, in the electrolytic cells, opposite, that is, electrical energy is converted into chemical energy. But in electrochemical or electrochemistry, we talk about how to produce electricity mainly. So for this, we use electrochemical cells. Best example is a Daniel cell. Best example is a Daniel cell. In this, we know there are two half cells. One is zinc rod half cell, means oxidation of cell. Another is reduction of cell with the copper rod. Zinc is used as anode, whereas copper is used as a cathode. At unit concentration, if the concentration is unity, then what is the potential of this cell? These two metallic rods are connected with a copper wire, and two electrolytes, means solutions, salt solutions of the electrodes, are connected with a salt bridge. And in the this is external circuit, internal circuit. Internal circuit is this is external circuit, copper wire. Okay. When the current circuit is completed, current flows, or since this anode, electrons flow from anode to cathode. Whereas current passes from right to left. That is the direction of the electrons and current. Always these two are opposite in directions. Yes, since the anode, zinc is dissolving in the solution. Solution always contains Zn plus 2 ions and SO4 minus 2 ions. Zinc is dissolving, leaving 2 electrons into the circuit. We can identify the electron flow of electrons or current direction by using a device, a meter. Now, this is the Daniel cell. In this, at a unit concentration, the voltage or the EMF of this cell, EMF, electromotive force of the cell, or electropotential of the cell is 1.1 volts. 1.1 volts. So in this, we are able to, without any external force, we are able to produce current, and we can convert this into electrolytic cell slowly. For example, when some external potential is applied into this circuit, external potential, this is cathode. External potential is applied, means same two half cells will be continued. Two half cells are there, same. Okay, in this same zinc rod is dipped, copper rod is dipped, and same only, but here we are applying the external potential. How? External potential into the circuit like this. External potential we are applying like this, means this is a rheostat. Rheostat is a device to change the amount of electricity. Okay, we can increase or decrease. This is in this second condition, first diagram, just it is a electrochemical cell to produce current. But in this, we have applied some external potential. How much? Here less than 1.1 volts, less than the 1.1 volts of this. Then what happens? Current flows in the same direction, electrons also same direction. Means current right to left, electrons left to right. So you should remember this point. Whenever applied potential is less than the potential of the cell, then the same current directions of the current and electrons. That is the noticeable point for the objective point of view for the competitive examinations. Whenever the same diagram, if you draw once again, or in the same diagram, if you increase the potential, external potential, this is what? This is a external potential. External potential. This is a battery. External potential which is less than 1.1 volts of this, less than this one, first one. So current continues be in the same direction. Electrons also same direction. But here slowly increasing, and external voltage, external potential. This is a zinc rod, copper rod. You have to notice this point what I am going to change. Yes, this is a copper, external circuit, internally these are connected by salt bridge. Internally by salt bridge, don't forget. Externally by copper wire. This is also one of the important points for a competitive examination point of view. Here also same diagram. External copper wire, this is copper wire, this is a cathode, this is anode from the beginning. This is also anode, this is a cathode. Copper rod is a cathode. Yes, same anode, cathode. Zinc rod, this is a zinc rod. Left side is a zinc rod is a anode. Right side copper is the cathode. And it is continued in the same second diagram also. Third diagram, what I am going to bring change here? Yes, this is again external voltage, and I changed the rheostat position, increased the current or decreased the resistance. Means here exactly E naught of the cell or EMF of the cell is equal to 1.1 volts. So exactly equal to the potential of the first cell. External potential applied equal. Then what happens? No flow of current or electrons. Stopped. Your bulb also does, if you apply any device, bulb does not glow. Here it glows more, it glows less, it glows no, it does not glow bulb here, any bulb. Okay. Here no current, no flow of current, and no flow of electrons. No flow of electrons or current. This is the important thing. Now last condition. Again you draw the same diagram with the two half cells, zinc half cell and copper half cell, copper electrode half cell. One is oxidation half cell, zinc rod, continuous zinc rod only. This is copper rod. These are connected externally with copper wire, externally with the copper wire, internally with the salt bridge. You don't forget this point. But here what is the change? External voltage, external potential is what is it? Yes, external potential is greater than 1.1 volts. Everybody should understand this. Slowly we are increasing external potential. Okay, here crossed more than the first one, greater than 1.1 volts. Then what happens? Reverse will be, flow of current will be reversed, flow of electrons also will be reversed. Means electrons will from right to left, current will be from left to right. Very, very important for competitive exam, JEE and mains and advanced, and also NEET level, nationwide any examination in chemistry. So I hope you have understood this. We can give a question also on this. He will give 4 options with 4 external potentials for a Daniel cell. When the concentrations of unity, concentration of these ions are unity, then what happens? When you apply externally, we applied 0.5 volts, for example. What happens? What is the change in the current of electrons or current? No change, because it is less than 1.1 volts. So like that you may get objective. Sometimes he will give an external voltage 1.5 volts applied. Yes, electrolytic cell will be converted into electrochemical cell is converted into electrolytic cell in this. So this is a electrochemical cell, this is electrolytic cell. So in this class, we have understood how to convert electrochemical cell into electrolytic cell. I hope you have understood. Thank you all.